Yama and good evening everyone. A very warm welcome to the National Library of Australia and to the Ann Moyal Lecture. I'm Marie-Louise Ayres, Director General here at the National Library. To begin, I'd like to acknowledge Australia's First Nations people, the first Australians and of course the first Australian scientists, as the traditional owners and custodians of this land, and give my respects to their elders, past and present, and through them to all Australian Aboriginal and Torres Strait Islander people. Just as an aside, I was lucky enough to be at Garma last week, where I attended a number of talks about caring for sea country and about the terrible problems with plastic waste washing up onto the beaches of East Arnhem Land. So this is very present in my mind at the moment. Thanks for attending this event, either in person or online, which is coming to you from the National Library building on beautiful Ngunnawal and Ngambri country, a country with a beautiful language which is being maintained by dedicated community members. It's such a pleasure to see so many of you here tonight for the second annual Ann Moyal Lecture, and to know that many are watching from afar, including, I believe, quite a few science teachers. Good on you, science teachers. This instalment of our flagship lecture series is named for Dr Ann Moyal. Many of us, including me, were lucky enough to know Ann personally. She was a beloved member of the library community, a Petherick reader, a Harold White Fellow, an established historian of science and technology, and always very forthright about what she thought the library should do. As a champion of independence in research and scholarly pursuits, she established the Independent Scholars Association of Australia in 1995 during the Against the Grain conference held here at the National Library. Anne herself is remarkably well represented in our collection. She conducted more than 20 oral history interviews, and she was interviewed 3 times herself over her very long life. The library also holds all of Anne's publications and her personal papers. Anne regularly discussed the best way in which she could support future research, writing, and the communication of science outcomes, deciding in the end to fund an annual lecture on the theme Science in Society. She specified that the lecture should be given by a distinguished speaker and discuss a contemporary question elicited from diverse academic fields such as science, environment, ecology, history, anthropology, art and technological change. Our speaker tonight fits the bill perfectly. Tonight, it is my great pleasure to introduce Scientia Professor Veena Sahajwalla. Professor Sahajwalla is an internationally recognised materials scientist, engineer, and a leading voice in the field of recycling science. Veena is renowned for pioneering the high-temperature transformation of waste in the production of a new generation of green materials at the University of New South Wales Sustainable Materials Research and Technology, or SMART Centre, where she is founding director. Veena is the inventor of polymer injection technology. I hope you're going to explain what that is for those who are ignorant, known as green steel, an eco-friendly process for using recycled tyres in steel production. In 2018, she launched the world's first e-waste MICROfactory, and in 2019, she launched her plastics and green ceramics MICROfactories, a recycling technology breakthrough. Veena has become one of Australia's best-known scientists and inventors, and in fact many of us feel we probably already know you quite well. Those of us who of course watched The New Inventors for years and years and years. She's also featured on Australian Story, Q&A and The War on Waste. She's been extensively recognised for innovation and the significance of her work through a host of high-profile awards, including the 2022 New South Wales Australian of the Year, and via her election as Fellow of both the Australian Academy of Science and the Australian Academy of Technology and Engineering. And you can see why we are so delighted to have her here tonight. We even have a book for children that features Veena and her work, which is upstairs in our bookshop. Please join me in welcoming Professor Veena Sahajwalla to present the 2024 Ann Moyal Lecture.
Thank you. Thanks very much, Director General Dr. Marie-Louise, for that really warm welcome. And it's indeed an honor to be here today. What can I say? Growing up in a place like India, where, of course, when we saw materials and products that were all over our homes and our communities, you never really wanted to throw anything away. And maybe that's what makes me the perpetual hoarder. I guess you could probably say that. But I think there was something innately fundamental about, when you're passionate about the environment and when you're looking to make a difference to your communities. And you're also thinking about, all kinds of exciting ways in which we can make things. Of course, that intersectionality between recycling and environment, manufacturing solutions, it can be a whole new exciting world. Doesn't matter how old you are, or if you're a young kid who's just, passionate about making things, and sometimes your passion for making things starts because you've actually broken a whole lot of things, much to the horror of your parents. So I guess, that's really, for me, is where the journey started. And fast forward all of these years at UNSW, at the Smart Center, this is something that we're all really passionate about. It's caring for our environment, caring for country, but also recognizing that somewhere in all of this mix are all of us as human beings. We all want to do the right thing. We all want to care for people. So there's also that added element and that complexity of how do we care for our communities? And of course, so many communities across Australia and indeed across the world are faced with challenges where waste simply stockpiles. And if that happens, it collects, goes to landfill. And of course, if you don't have solutions, then it can actually be quite disappointing. So for a lot of people who are really passionate about the environment, who want to do the right thing, who want to play a part, what I hope we can share with you some of our stories of our work at UNSW, not just the science and the technology, but also looking at how waste is indeed an opportunity. And of course, you'll hear of terms, I'm sure, as you might have already, circular economy, and we'll stop and reflect on some of that as well. What does it actually mean in practice? So to acknowledge the fact that our work at UNSW, funded through, of course, various research entities over the years, yes, indeed, looking at the work that we've done in the past around green steel and funding through Australian industries and ARC, it's been an important part of the journey. But to acknowledge Australian industries in that mix, the steel industry partners who were looking at what we were doing in a tiny little furnace in our labs at UNSW, were as excited about science enough to be able to go, there's something different here. Let's collaborate. And I think, to me, again, a lot of credit goes to Australian communities, Australian businesses, who in many instances look at exciting science, look at the opportunities, and want to imagine a sustainable future. And this is what we're talking about here, that collectively, through collaboration, through partnership, we can actually design and develop a sustainable future. The other part of our work, indeed, with communities, funded through Sustainable Communities and Waste Hub, as part of the National Environmental Science Programme, is something that we have the privilege to be a part of. And in my role as a hub leader, I can tell you absolutely what a joy it is to work with so many different communities across the country, whether they are our NGOs, our local governments, our business partners. Everybody wants to collaborate and play a part in taking that science and applying that science. So that's the important part, is you've got to be able to demonstrate how we can achieve those goals. So the ability to understand materials and how we recycle doesn't just stop at the point where we collect materials. What we have to importantly ask the question is how are we going to actually translate a lot of those ideas into real-world practical outcomes for our communities. And this is where, of course, the entire picture sits. There are many parts to it. It's about doing the science, but it's also about applying that science. But then importantly saying, well, if we were to think about a holistic solution, what are we actually going to make? So that making part of it is also important. If we start to think about what Australian future is going to look like, then absolutely bringing manufacturing, bringing communities at different scales, in different towns, whether you're in an urban center or in remote and regional and indigenous communities, we can actually all come together. And indeed, just like you, Director General, I also had a privilege a few months ago to be invited to Arnhem Land to actually speak around this conversation as to how we do something together about all of that waste, indeed, that is collected in our communities. And of course, more importantly, to be able to find those solutions. So it's not enough to be able to say, let's talk about what these challenges are, but if we can think from the lens of solution, and if we can think what an opportunity this presents itself, then what are some of the technological advances that we need to make? So indeed, this is what we can picture a future. Yes, it's through collaboration and through innovation. We can all play a part. So indeed, when you think about who are the owners of waste, who are those that have to deal with? Yes, indeed, it's a local government. And of course, all the waste management organizations and the not-for-profits and those communities in many of these different regions that have to deal with it. You don't necessarily have the answer in an instant, but you don't have to think about this as if you're having to grapple with this challenge yourself. What if you could work through this kind of collaboration where circular economy actually is part and parcel of this ecosystem where indeed waste is seen as a resource for manufacturing? And if that is the case, then we've got to think about what that ecosystem looks like, which means we've got to work with designers and manufacturers, those that know how to set up these solutions and indeed use them. So it's not enough to be able to make something. You're not just saying, well, I'm going to make something and hope that somebody wants it. You actually collectively come together, which is why circular economy works when we start to talk about collaboration. And yes, maybe it is about those innovations that have to yet be discovered. But this is the joy of discovery. This is the joy of coming together, where somebody might say, well, actually, I've got this problem with waste plastics, or I've got this problem with waste tires. How do we bring all of this in the form of solutions? So indeed, if you're an end user, so think about end users. Who are they? Well, that's us, again, right? Because we're part of a community. We're part of a system where we might actually use the health services. We might actually be part of a manufacturing business or retail, or in all of these cases, we are the end user group. So if you actually think about it, we can all play a part in so many different ways. What we have to challenge ourselves, though, is to not be disappointed when somebody tells us, oh, actually, this particular plastic, oh, no, you can't recycle it. It's non-recyclable. In fact, if anything, I think at the Smart Center at UNSW, we get really excited and to some extent almost that sense of bring on that challenge, that how can we say it's not recyclable? Well, you know what? Maybe we haven't yet discovered that. And so what we want to do is we want to bring together that alignment between recycling and, of course, manufacturing and remanufacturing. And in all of this ecosystem, if we can picture a future where, of course, if waste is a resource, then, of course, you've got to be able to find a way in which we can put it into the hands of those end users. But let's reflect for a moment what we are doing in our Sustainable Communities Hub. We're looking at that bigger picture. We can't just allow our waste resources, in this case, look at all of those tires, to simply collect in our landfills or in our communities, because nobody would want that. So the partnerships that we've developed and the support through the National Environmental Science Program is about saying, let's ask ourselves all of those challenging questions. Yes, it's about safety, so safe circularity. It's about saying if we have to enhance those opportunities. Who are our partners? So indeed, partnerships with Tyre Stewardship Australia allows us then to bring that together. The Department of Climate Change, Environment and Energy and Water, we're working together. And this is what we should be doing, is about how this work allows us to address some of these challenges, but also equally importantly say, what if we could put it into new manufacturing solutions? And we'll come to that a little bit later. But these are the reasons why we need to be mindful of the fact that even when a waste material is just sitting around in landfill, it's not just always going to be completely inert. If it's got some elements and it breaks down and it then causes pollution into our land, into our water, then of course we can't have that either. So we've got to be mindful around safety and of course its impact on the environment. In this particular case, what you're seeing is the fact that dust that has been created as a result of that wear and tear, and of course when these particles are liberated, as you might have heard of terms like microplastics, whether they come from plastics or tires, these are the kinds of challenges that we know we are facing. So therefore, what we have to do is recognize that, yes, there are challenges, but before this ends up becoming a massive pollution problem, why don't we look at a whole range of different solutions? But again, the question is, how do we have that community involvement? This is what our Sustainable Communities and Waste Hub is all about, working with local councils. Here's a great example of working with Salamander Bay. And what we are doing here is looking at those opportunities where in a community, let's say if you were to imagine a future where small-scale manufacturing facilities, high-tech, advanced facilities can be created where we do create materials and products. Well, just imagine what you have done. You've gone beyond recycling, haven't you? What you have done is you've actually created a whole new way in which we're remanufacturing materials. We're rematerializing these kinds of materials, putting them back into circular economy. So, of course, we should enable that way of thinking in saying it is possible at the right scale for the right materials that we can create new solutions and new opportunities. And imagine if we did that. In our communities, we would of course be creating new jobs. And this is the fundamental way in which we can address that holistic solution, environmental benefits, community benefits, and of course, economic benefits are coupled with that. Because if we recognize that there is a way to create new job opportunities, then we are hopefully inspiring our communities to look at those waste materials, not as something that just sits around and goes into landfill, but rather to be able to put that back into remanufacturing. So that ability and that capacity to think in a much more holistic way is really what circular economy is all about. Is let's create those regional solutions, those local solutions, and indeed this is where we can help different communities actually participate and collaborate. So yes, I might be somebody who's in the business of working in a council, I've collected waste, but I can partner up with a local firm, a local manufacturer or an engineering firm that actually knows how to take those resources, put that back into a supply chain. So now we're suddenly starting to talk supply chains. Think about how sophisticated this conversation can start to become. Everybody can be a winner out of this type of solution. So let's look at what else our communities are facing. The challenges associated with batteries. Of course, as we all know, and a few nods in the audience, that yes, this is actually what we have to do to take on some of these more complex materials. So when we think about waste batteries and how much ends up not being remanufactured and not being used in Australia, it is heartbreaking because they do contain valuable metals. If they do contain valuable metals, think about this list in front of us. We've got nickel and cobalt and manganese, and the list goes on and on. Why would we not harvest these materials, these end-of-life materials, in a way that the value is created right here? if we could demonstrate that we could create that value right here, then of course it's not necessarily a waste, is it? It is actually effectively a mini. All have batteries and our old devices at home. Well, we're kind of owners of little micro mines, aren't we? So you can start to picture this whole ecosystem in our communities that builds from the fact that collaborative efforts, and yes, working with our local governments and agencies that are doing a great job in collecting, but that's not where we need to stop. We need to have safety, of course, but we need to start to think about how we're going to process those so we can create those metals and materials from our end-of-life products. And of course, you can see where I'm going with this, because if indeed energy storage and our transition to a net zero future has to be done, and if Australia is committed to that, then of course we know that all of these important metals are going to be important. And this is where, of course, connecting with what we might see today as a challenge can be converted into resource and value and economic opportunity for our communities. So, of course, how do we do that? Someone might say, well, it's all well and good, really nice to have some of these big picture conversations. What can we do in practice? This is where the journey starts with research. The research of saying, all right, if we've got lithium-ion batteries, what does it contain? What if we could actually go into that battery and see that it actually contains all of these important materials? So yes, there's basically metals in there, like copper and aluminium in the form of foils. We also have got that mass inside, which is those powders of cathode and anode that could well be rich in metals like cobalt. The challenge, of course, is how do you isolate that? Because it's not actually present in that metallic form. If it's not present in a metallic form, how do you get to that metal? Someone might say, well, metals are made in smelters, so, we always need to have that. But yes, what are you going to design and think about extracting those important metals so that you can make sure that that waste is not simply seen as waste, but rather the opportunity to monetize that in our communities. And of course, if we continue to explore what the future is going to look like, absolutely. Look at some of those stats there. What it's basically telling us is that the world is expected to process 11 million tons of spent lithium-ion batteries by 2030. We know, of course, that the annualized spent lithium-ion production volume is expected to increase by more than 1 million tons by 2025. So if you've got all these big numbers around the fact that we're going to have use of these products in our communities, well, of course, it's logically connected to the fact that the end of life of those products is also going to be inevitably growing. We can't just hide ourselves and say, well, let's worry about it when that happens. No, we need to start to think about that now and prepare for the fact that all of these solutions are going to create new opportunities. Because if we don't do that, of course, what will end up happening is we're going to stockpile these materials and we're going to end up putting them into landfill. So we don't want to do that because, of course, we know some of the hazards associated with throwing away these batteries. We know that they can cause environmental harm. So we don't want to do that. So apart from recognizing that there is economic value in these materials, we also want to protect our communities. So back to that point, when we talk about safe circularity, so we talk about all of these questions, understanding fully well that these are useful products, but we also need to respect these products at the end of its life, not just because there's economic value in them, but because, of course, if we don't take care of them, then it has potential to cause some harm. So let's actually see that as to what it is, whether it is indeed different kinds of batteries and all those elements. And yes, we work towards getting better efficiency outcome, better performance. But what we are talking about here is a whole new way of actually going after those important elements. And this is why we refer to our solutions as micro-recycling. Why? Because if you look at how much we have in, for example, our electric vehicles, we can just see that EVs are going to increase in Australia. So the opportunity is there. We fully expect that by 2030, just look at how the numbers are indeed increasing. But if you actually go back and have a look at that, the conventional batteries contain those several kilos and tens of kilos of important metals like lithium, cobalt, manganese, and indeed graphite. We've got all these important elements locked away. Why would we not go back and literally look at it at the micro level and go, here's an opportunity, let's harvest that. So this is what it shows you. Where is it actually sitting? All those different chemistries or different batteries. And you can see that, of course, we've got an opportunity to go, you know what, great, fantastic. I've got all of that nickel, for example, that this is showing you, all that graphite, all these different chemistries. Now, why don't we start to imagine, if we're already collecting it through various stewardship schemes, why don't we start to imagine that what we have at our fingertips and in our communities is basically these kinds of mini mines. And those mini mines collectively become literally a powerhouse of elements. So literally what we are sitting on is a powerhouse of different elements. And of course, when we think about the prospect of recycling these, we can also see the economic potential in these. And of course, what CSIRO did quote is that in each ton of lithium-ion battery waste, we are looking at an economic potential there of thousands and thousands of dollars. And this is why we need to start to look at it. We've focused our attention and talked about lithium-ion batteries, but then there's so many other types as well as we can imagine. So here's an example of something as humble as a simple zinc carbon battery that's also a source of zinc and manganese, and the list goes on and on. But ultimately, here's a whole collection of different types of recoverable metals and rare earths that are present in our waste batteries. Look at all the opportunities that it presents itself. We, of course, can do so much when we start to think in a holistic way that we harvest each of these different kinds of materials and go after, because look at the commodity values in terms of tonnages and the dollars per ton that we're talking about, and compare that, of course, to traditional materials, like when you start to think about iron and manganese and aluminium and copper. I mean, they're not doing too badly either. Copper is an important metal for electrification. And of course, if you start to look at the prices from 2022, you're talking about $7,000 per ton. So you've now got an opportunity to go back and say, after all of this, what have we learned? We've learned that just simply thinking about recycling as just this simple way of what we put in our yellow bins is job done. Clearly, that's not the answer. What we're really saying is that alignment between recycling and manufacturing and making all these different kinds of important metals, that's where the future lies, because the opportunities at our fingertips, we can actually collaborate, work together. But to achieve that, we need to innovate. Because what we're saying is the traditional 3 Rs of reduce, reuse, recycle is clearly not going to be enough to be able to address some of these complexities around, of course, the kinds of waste challenges we're looking at. So what we are proposing is that 4th R of reforming, going in, looking at what those compounds are. So yes, indeed, if in your battery you've got lithium cobalt oxide in a form that is a complex chemistry, we don't just give up and go, well, let's somebody else worry about it. What we're saying is, no, we can actually develop these solutions, recognizing that right down at the elemental level, we've got an opportunity. But then we might say, well, that's all well and good. We've talked about, important metals. What about all those non-metallic materials, right? We talked earlier and we said there's plastics and tires. And indeed, I've put coffee residue as well on that list. And you might go, well, wait a minute, how's all of that? What does all of that have in common? Well, what's exciting is in our work that we've been carrying out on green steel, we've actually shown that these different kinds of complex materials, and I call them complex because, of course, structurally, there's nothing simple about it. Yes, they might be simple to us as presenting itself as tires and coffee, but what we have in there are elements like carbon and hydrogen, and we can unpack that. And how do we unpack that? Well, we're not saying that we need to be able to have a whole new complex system to be able to make carbon and hydrogen. What we are really saying is, if you look at that list, is how do we use that as part of our manufacturing process? So in the making of green steel, that's exactly what we've done. Our polymer injection technology, which liberates hydrogen molecules inside a steel making furnace and uses that hydrogen as part of making steel. So we're able to reduce that iron oxide and convert that into iron and that into steel. So you can start to see that when we have these types of discussions, what we're really talking about is going beyond that traditional 3 Rs. We're not just saying that like-for-like conversion. Yes, in some instances, plastics can come back to life as exactly the same plastic, like our PET water bottles. We acknowledge that there are some products that can be converted like-for-like. There are some types of glass that can be converted into exactly the same thing. But when you can't do that, you don't stop and just give up. You go, wait a minute, but fundamentally, if we've got these useful elements in there, why don't we look at it from that point of view and look at what those elements can do in terms of enabling us to actually start to think about what green manufacturing could look like? What is that look around sustainability? It's not just about saying, well, somebody else in some other part of the world can worry about it. We're saying we've got Australian science, some of the pioneering scientific work that we've been doing in looking at recycling and looking at remanufacturing. We can actually demonstrate through this science that we can indeed go to that 4th hour of reform, and we can, of course, demonstrate that now we can liberate those carbon and hydrogen, and we can use that in the process of making steel. So ultimately, these kinds of technological advances that we're showing in making different kinds of materials are possible if we start to think about circular economy as a way to actually think mainstream production, that manufacturing should be looking at circularity and safe circularity as mainstream. And yes, of course, you've got to make things technically viable, you've got to make things economically viable, but that's all part and parcel of doing your research. And this is, of course, some of the work that we have done in the making of green steel at UNSW, and indeed acknowledging, as I said, our industry partners who've been part of this journey. What you're seeing there, and as I promised, yes, I will take a moment or two, so please indulge with me in what polymer injection technology is all about. This was one of my first inventions, so it's like one of those things that, when you become an inventor, you never think it's actually ever going to work, because you just think it's in my head and it's a thought bubble. And in this case, literally the bubbles that are coming out that you see in this liquid slag that's bubbling away, that's what this phenomenon that we basically showed was possible by the use of waste rubber tires. And we actually have got that liquid slag, we're looking straight into a small lab scale furnace. And that bubbling phenomenon that you're seeing is called slag foaming. But the way we have made it possible by using waste tires, we were able to prove that indeed that hydrogen was participating in the chemical reactions where in that liquid, that iron oxide was reacting with hydrogen, and you were converting that iron oxide into a metallic output. So it was indeed that hydrogen that was playing a part in converting that iron oxide into iron. And indeed, of course, all of the associated phenomena, how we deliver that in a practical setting in an industrial furnace, is through that polymer injection technological solution that we have shown that indeed that's what happens inside a steel-making furnace, except the difference is on a large scale, 50 to 100-ton furnace, you can't actually take your camera and poke it in and go, oh, let me just have a sneak peek here. So indeed, what you have to do is you have to be able to design and think about how you look at it experimentally in a lab. And that's part and parcel of the excitement. Of course, in the early days when we were planning these experiments, it was almost one of those, that sense where you go, oh my gosh, every time we started that experiment, it just failed before it even did what it was meant to do. And I thought, oh, well, it's always going to be the thought bubble in my head. It's never going to be a real gas bubble inside these systems. And of course, lo and behold, when the experiments actually started to work, I think the joy was palpable in the room, because it's pretty much every researcher who's been spending time making these experiments work, and we're all sitting there going, this is actually working, or are we just now imagining? And of course, indeed, we did it over and over again, as you can imagine, to be able to, of course, prove that under different conditions, these experiments were indeed working. So that's what polymer injection technology is all about. It allows us to carry out these reactions, liberating these important molecules inside a steelmaking furnace. That's what you see happens in an industrial setting, where that lance that you see is injecting these rubber crumbs into the slag. That liquid slag is where iron oxide is, and that slag layer has got many important functions that it does inside the furnace. But also, let's come back to another important point that is clearly the obvious answer. If we've managed to liberate that hydrogen, and if it's that hydrogen that's actually doing the job, instead of some of the more traditional coal-based materials, well then guess what? We're making sure, as part of these solutions, that we're creating that scientific foundation to show that it is possible to lower our carbon footprint through these kinds of solutions. So the fact that we can indeed show the decarbonization and the possibility of using these types of solutions, which is what polymer injection technology is all about. And sure, there can be many different ways in which you can deliver hydrogen to be able to bring about that conversion of iron oxide into iron. This is one of the ways to do it. And of course, as the picture shows there, we've implemented this in EAF, that's electric arc furnace steelmaking process, where we can indeed introduce our technology. But there's another exciting new frontier that we're developing. My all-time favorite drink, coffee. So as you can imagine, over many, many countless cups of coffee, it is eventually that realization that comes upon you that you go, well, okay, wait a minute. If we can make that work with waste rubber tires, something that's good enough for all of us to drink, all that waste residue coffee is still very rich in carbon and hydrogen. Now we've got a resource that we all love to consume, at least I can say for many of us, we love to consume. But the benefit here, the added benefit that we can demonstrate as part of the solution is that solid carbon that's present in coffee waste actually has now dissolved into liquid metal. And why we know that has actually happened is because when you, in fact, look at that structure, that we've got that microstructure, we can actually go back, look at that, analyze it, and show that indeed that presence of that solid carbon is actually there. That is an essential element in steel. Carbon and many other alloying elements play a very important role, and that's what defines different kinds of steel. So indeed, when you talk about, plain carbon steels or stainless steels or alloyed steels, that's what these solid elements are. They enable steel to do what it does, perform all those different functions. And this is where, of course, what we have proven is, you can actually take some of these sustainable materials and create different alloys. So ultimately, really, when we think about the journey so far, what we've basically said is that, it is possible to have those thought bubbles and those ideas, and sometimes ideas that sound really, really crazy also do come true. So the transformation happens when we all collaborate and we work together. That, of course, means that for all of us, it's a way to feel empowered. No matter where you live, in which community, you can be part of that supply chain. So indeed, you might think about it and go, wait, okay, I could actually be collecting some of that waste residue coffee, or could I also be collecting some of these other plastic materials that can then go back into production? But before we do that, just to pause and reflect that, yes, there are different kinds of plastics, as we were saying before. And it's not just every kind of plastic does exactly the same thing, as we know. So indeed, some of the solutions that we have developed shows that even from waste electrical and electronic equipment, where we used to thinking, well, if it's electronics, isn't it all metals? But you know what? There's also a lot of plastic in these kinds of electronic systems. So, for a long time, when people focus on metals, you kind of realize very quickly, there's this pile of old printers. Who hasn't had that in their homes, in their offices? And you look at all that plastic casing and go, I'm going to put it away. The council has a collection day. I'm going to take it, drop it off. Yes, of course, we all do the right thing, but you've got to ask the question, then what? What does the council actually do with it? Or what does the community do with it? And this kind of deeper, more sophisticated conversation is where, of course, when we acknowledge our industry partners, over the years, we've actually shown that it is possible to go to some of your industry partners and have these conversations. And Australian companies doing a fantastic job in saying, you know what, let's work with you. If you can prove something, we want to be a part of that. But you might then say, well, that's electronics. Now, what else is then in the form of plastics? Again, you can go back and say, here's another form of plastic. A plastic that is thermosetting, difficult, of course, people might say, to recycle. All right, well, let's put it on the table. Literally, of course, the list goes on and on. And there's no end to, of course, all of these materials. Now, yes, absolutely, we should be looking at getting rid of those single-use plastics. And I'm sure, as you've seen, many, many states across the country do exactly that. But we've got automotive, electronics, all of these different types of systems where we do have plastics that are indeed of high quality. And of course, my all-time favorite, the category 7. Because, of course, we very lovingly call it the other category. Because it's just so complicated. We just don't even want to refer to it by their names. We just go, well, it's the other. But the reality is, if you have a look at that list, these are useful products, like we were saying, in our electronics, in our cars. So, of course, what we have shown as part of these solutions is to be able to say, if there are some kinds of plastics, so the example of what comes out of our IT equipment, one of our microfactories that we have recently launched actually takes some of that plastic and indeed puts that into microfactories for making these plastic filaments. So, what we have here is the picture that shows you some of that waste. That waste then gets converted into plastic filaments. And indeed, what we're looking at is the opportunity to be able to put that into 3D printing and print some of these products. So I will actually show you what kinds of products we've been making just in a little moment. But just to be able to put a few more examples on the table for you. All of these types of materials, like you might look at something like that and go, oh, safety glasses, of course. You can't do without that. We all know the meaning of PPE now after COVID. But people who work in industries have always been using PPE to protect their eyes, to wear safety boots and so on. So all of this is part and parcel of what we use as human beings in our work environment. And then, of course, all the others. So the list goes on, but one might say, what have we actually achieved with that one simple example that I was saying? In this microfactory, we've actually converted those into plastic filaments. These plastic filaments, of course, as you see there, being produced in Sydney at our industry partner site, at Renew IT site, that allows us to take different kinds of plastics, and you can see the black one there, that's the ABS one, that's basically from 100% recycled e-waste. That's the one on your right there. And the one on your left there, that's recycled PET filament from 100% expired medical consumables. So you can start to see that if you can actually recognize what these different kinds of plastics are, then there is no reason why you can't produce products that are economically viable and useful And of course, as we all know, if someone's got a 3D printer, guess what they're going to do? They need plastic filaments. And of course, for Australia to be able to say, guess what? We're now going to be the world's first to produce 100% recycled filaments at the site where the waste is indeed being collected. And this is a whole new mindset and a whole new way of thinking, where waste is now seen as a resource, and somebody who might have been collecting waste is saying, you know what? I'm now a manufacturer. I can be someone who can be an advanced manufacturer making products like that, because of course, these things are worth a lot of money. If we don't make it ourselves, guess what? We have to import it. But why would we do that if we can actually manufacture these in our microfactories? So these are some of the examples of the products that we've made. What you can see on the extreme left here is that filament microfactory line. That's there at Renew IT in Sydney, and of course, all of the other products. So indeed, you can see some of the clamps on the right-hand side. So all those kinds of industrial products. So when we actually start to think about remanufacturing, and rematerialization in this case, it is possible to completely change the way we ask the question as to what do we even mean by recycling? What do we even mean by sustainability? This is what we mean. We are creating products and solutions that have not been made before through this mechanism, and of course, doing that in microfactories. This is only possible because we've come together and we've collaborated with our industry partners, our researchers, and of course, acknowledging that the very first microfactory set up at UNSW as a pilot line was what we had to do. So yes, indeed, in terms of taking ideas from a lab scale, piloting it, working with your industry partners to ultimately get it out into industry is what we need to do to be able to transform those ideas into reality and create impact. Of course, now when we start to think about plastics, there's the other important kind of plastic that we probably don't even think about as plastic. Our clothes, right? And you think about all the synthetics that are there in our textile. And of course, the world is facing these challenges when you think about, of course, all the microfibers that are coming out from our waste textiles. And in many parts of the world, they are indeed either landfilled or incinerated. And that is really sad. Absolutely, we should be reducing our consumption of these kinds of materials. We should actually be mindful of the fact that our habits and the way we live is not going to be sustainable if we continue to live the way we have. But we can do better. We can acknowledge the fact that this is what it is, but again, can we actually lower our consumption and have a system, as we were talking before, where some of these materials can come back into the supply chain? But if you want to bring them back into the supply chain, you've got to ask the question, well, what are you going to actually make? Yes, in many instances, if possible, you could do fiber to fiber. Indeed, that's one solution, that like-for-like conversion. If it is not possible, because it's a blend, it's a mixture, and it's complicated, well, what else could you do with it? And these are the kinds of solutions that we need to develop. It's not about saying, well, there's one size fits all, I've done it, I've read about it, problem solved. No, of course not. Even with our textiles and in those synthetic materials, those plastics, there are so many different kinds of materials there. So it's not just about our metals and our glass. We know that in all of these cases, we have to do a better job. And indeed, why? The question is, when we think about sustainability, yes, it's about the environment, it's about the economy, it's about the material itself. We can't afford to keep taking from our planet and just assuming that there will always be more. Of course not, we know that. So when we talk about reforming our materials back into production, back into supply chain, we're actually helping the economy, but we're also keeping that waste from becoming a pollutant. That's what we're doing, because we're saying, no, we're not going to simply allow our waste materials to sit in landfills because we see it as a resource. We can't lose that opportunity to be able to do really smart and clever things, because that allows us to create new businesses. And this is what the holistic system actually encourages us to do through collaboration. We've partnered up, of course, indeed, with various industry partners to, again, bring some of these solutions to life. And you might say, well, okay, what's something like waste textiles got in common with waste glass? Why have I got a picture of waste glass up here? Well, guess what? One of the other microfactories that we have started up with our industry partner does exactly that, brings together some of these solutions. We operate actually in a way that all these different kinds of materials can actually be put back into production, and indeed to be able to make materials and products that are fit for purpose, which then brings us to the next microfactory, our green ceramics. And indeed, you can see there that, yes, you've got a truck that's collected tires, and I don't know if you can see closely enough, but in that truck you also have waste mattresses. Well, we can't exactly say, well, no, I don't use mattresses, Unless you're camping all the time, then it's different. But you do use mattresses. Many of us do. So imagine what happens to all of this, again, when councils collect it, because your council's going to go, yep, I'm going to collect it. But what happens to it then? So those are the kinds of questions that got us to, of course, work with our industry partners. Our green ceramic microfactory has indeed now created this product where we bring together these completely different materials of waste glass and waste textiles and create these green ceramic tiles. And indeed, this production is actually being done in Nowra and on a council tip site. So this is the best part of it. Why would you call a council site as a waste landfill site if you can actually say that it's part of the manufacturing ecosystem? Imagine if that's how we talk about in the future, that we are going to be streamlining and thinking about our ability to manufacture. And this is all possible because we know, one, we're all passionate about making it happen. We know it's important for our planet, but we also know it's important for our people. We know when we start to think about what are some of these new jobs that we're going to create through these solutions. So these are the kinds of solutions we've created. Our industry partner, Kandui, and we, of course, were really privileged that we received basically a grant through the Trailblazer Scheme for Recycling and Clean Energy that allowed us to actually work with our industry partner and commercialize this technology. So this is indeed now industrial, it's commercial, as I said, working in Nowra and making all kinds of pretty cool and funky products, dare I say, not available anywhere outside Australia. There you go, something for us to be all proud of, that this is what we can do, show to the rest of the world how it's done. So I guess ultimately what I just wanted to leave behind with you, those thoughts that allow us to bring real circular economy to life by saying we've got to think about all elements in our technosphere. This technosphere that we know, technology, products, and materials, and of course our desire to do the right thing from an environmental point of view, from a human point of view, is so important. But this is only possible if we're actually going to come together and collaborate, and also to be able to do the science outside the lab. So we've done the science in the lab, proven it, take it out into community, into businesses, and show that we can actually deliver a win-win outcome for our communities, for our people, and for our planet. Thank you very much. Thank you.
Thanks very much, Veena. I'm now thinking, we'll all be thinking about our waste slightly differently. I knew that my coffee grounds were carboniferous because they go into my compost, but now I'll think about them differently. And when I drive my electric car, I'm now going to think I'm driving around on a mine, which I had not thought before. But more seriously, you mentioned, of course, that you'd been up in Arnhem Land, and of course the whole issue about local factories is important, because the problem they have there is the volume of plastic. And just to give you an idea, when they're cleaning up beaches up there, they can be removing 1 tonne of plastic per kilometre of beach per day. and they have no facilities for doing anything other than burying it. So you can imagine the potential for a local small-scale factory right on the ground. It would be fantastic. So it's a really thought-provoking lecture for us, especially for those of us who are not scientists, and I think can sort of now grasp these materials have got stuff in them that if you're determined enough and you refuse to take no for an answer, and you put together kind of imagination and science and then partner up with industry, quite amazing things can happen. We do have some time for questions this evening. The presentation, not many though, presentation is being live streamed. So if you have a question, could you just put your hand up and wait for the mic to come to you so that those who are watching from home can hear you. So, okay. Okay, question here from Bronwyn. Okay, good to see you, Bronwyn.
Hello, I am indeed Bronwyn. Thank you so much for a really exciting, inspiring talk. It's always so great to be able to think about the environment and what we can do to solve the problems in a really positive way. And I'm thinking about that, and you've drawn attention to the bulk of batteries we're going to get, especially as we move towards more EVs and indeed a whole lot of other, home batteries and so on. Do you think it's possible to engage industry partners from the beginning? Because you're doing a magnificent job of having to reverse engineer and figure out how to deal with very, very difficult, complex materials. But shouldn't the people making a profit from building these things, knowing that they're creating a new environmental waste problem, be starting to collaborate and think about, okay, how do we build a battery which makes it easier for them to be recycled at end of life?
Yeah, no, a really, really good question, right? Because, you could effectively ask that question out of so many different kinds of products, which, of course, people it's an afterthought. And what we're really saying is it should be a forethought. And even better if we all, collaborated together right at this onset. And I guess part of the reason why in some of this work that I've talked about with batteries also is for us to be able to say, if we were to imagine that we are able to produce some of those materials in the chemistry and in the form, we don't have to always say that in an attempt to recycle, we have to go back and emulate exactly what it was at the start of that life. What we want to be able to do, and indeed working with some of our industry partners there, is to be able to say, right, okay, let's now imagine if we were to end up making a new alloy or a new chemistry, how are we going to use those? And that helps us be really, really agile. So it's not about that exact like for like conversion. So that's why when I was talking about producing metals or metal oxides, it's about then saying, let's understand what it looks like in service. So yes, we will look at those materials, of course, doing that detailed study to understand how it's changed and that change and the transformation, so that then if we can regenerate it. So we start to think about the regeneration as the way to think about circular economy, that what you're really doing is regenerating it, but you do that with a purpose in mind, with the purpose is ultimately it's got to have the right performance outcomes. So when we talk about recycling, regeneration, remanufacture, it's for what purpose? Well, it's got to do the job it's meant to do. And so part of this holistic solution is also taking that into consideration. So yeah, absolutely. A lot of the work that we have indeed done and continue to do, so that's part of our ARC hub on micro-recycling and batteries. That's part of the work we do, is understanding the scientific fundamentals, but also working in collaboration with industry to be able to say, well, what are some of the newer materials that could be brought back into picture? So yes, indeed, if something like graphite that I was referring to that is in there, and you indeed can't find that resource, what we have shown through some of the papers that we've recently published is we've actually taken waste-hard rubber, and we've shown that we can create a new form of carbon that then allows us to show that its performance is actually pretty good. So that's also another way to bring many of our industry partners on board, because let's face it, not all of them have been in this business long enough. But what we're now saying is we can fast track and accelerate using that science, because time is of the essence. You know, we need to be able to translate that science as quickly as we can, and that also means that we've got absolutely, as you say, industry partners on board through the journey.
Another question down the front here.
Thanks very much. Thanks, Veena. I've got a three-part thing. One is an obvious fanboy moment. So, absolutely inspiring speech. I must admit that I did have an opportunity to meet you before, being one of my heroes in plastic and resource recycling when we got together at the Australian of the Year Awards. So I'm so glad to have you back in our hometown doing this talk.
Thank you.
Thank you so much for coming. It's incredibly informative. And the second part is a shameless plug for anybody at all that's feeling helpless of what can I do, how can I get involved with all the small plastic stuff. We started a local charity called Lids for Kids that is now spread far beyond just small plastics and microplastics. We're now recycling absolutely anything that a household, business or school uses that's smaller than a credit card. So all of your blister packs, not quite rubber tyres, which is very inspiring, but we collect all the batteries and nuts, bolts, screws, nails, washers, bread tags, sunglasses, e-waste. So all of it can come to Lids for Kids now. So anybody that all is interested in these microfactories, we're completely inspired by the work that UNSW has been doing. So you can come out to our little... I wouldn't be as grandiose to suggest it as good as a microfactory as yours, but it's all hands-on, it's all volunteers. You can come out any time to see what we do there and join in. We're just regular mums and dads doing this. The third part is, and where we get caught up, which is to my question, we're recycling all the polymers we possibly can. We're separating number 2s from number 4s from number 5s, making playground equipment and furniture for kids' schools. And another shameless plug, we've just started making the world's first recycled plastic skateboards here in Australia, which is cool. How hung up should we be in making sure that the next recycled product that we're making is single polymer? Because if we have to commingle the product to make it fit for purpose in the industry, one of the things ethically I get hung up on is if I commingle the product with 2 different products, like I love the green ceramics, that's absolutely awesome. Can we at least be reassured that, hey, we gave it another life, it's a second product, even though that one maybe not be able to recycle again and is an end-of-life product, can we at least still be grateful that at least we've kept it out of landfill?
Yeah. And so the answer to that is very simple. It's not about everything being always just a single stream. So remember I was talking about performance, right? So the purpose there is performance of a given product. So if you were to look at a particular polymer and you said, right, I'm going to put into skateboards and I need this clearly for that particular high performance application, yeah, you've got to manage that very carefully. And then it is up to the users to make sure that it's returned back. And so it doesn't get commingled amongst all the other polymeric materials and general rubbish. But I think the point here is that to then say, okay, in some instances, like if we were talking, for example, our green ceramic tiles, what we have proven is that that hybrid that we have, that mixture of textile waste and glass waste, at the end of its life, when the tile is damaged, it can actually go right back into a microfactory and it can be remanufactured again. So this is the point. It's not about saying, well, it's all this way or it's all that way. It's about knowing that if you were going to manufacture a product out of second life, third life, and so on, what you want to know is how you're going to measure its performance. Is it fit for purpose? Has the quality in any way deteriorated? How much do you need to control? So it's like any other manufacturing process, right? Your supply chain and what's coming into your manufacturing process has to be controlled. And you've got to be able to know and analyze and say, right, no, I will stop it right there because this is not good for my product. And this is how, when we start to think about manufacturing out of waste resources and end-of-life products, and if we apply the same quality controls and the same checks and balances as how you would think about manufacturing that has been done so far, there is no reason why circular economy and waste as a resource can't be seen from that exact same lens, that we've got to manage these materials and your supplier has to tell you what's in that material that they're supplying you. Thank you. Thanks.
Okay, well, thank you very much, everybody, for coming along. You've given more food for thought. One of the things we're doing at this library over the next year, you would be surprised how much plastic we use to care for our collections. A lot. So, you know, reducing, reusing and recycling is still really important, but thinking about that reform, the fourth R, I hope we're all going away thinking about the fourth R at this point. We have run out of time, but I hope you can join us upstairs for refreshments. And for those who'd like to watch it again or share it with friends and colleagues, you will be able to do so via the library's YouTube channel. As we bring the formal proceedings to a close, please join me in thanking Scientia Professor Veena Sahajwalla and once again acknowledge the generous bequest from the late Dr Ann Moyal and her estate which made tonight possible. Thank you. Come back to the library again soon.